Okay, here we go again. This one is something that I just put on YouTube, and I would like to start off by saying, let's give us the parameters. So here we've got, this is going to be the 6 mile range, and by using the 6 mile range it just allows us to be able to see quite clearly on here. We're going to be in relative motion. Relative motion, and we're going to be heading north 0, 0, 0, and we're going to be doing 12.5 knots. I'm going to use then relative vectors. And those vectors' length are going to be 12 minutes. Okay, so let's put that on where we are now. So this is my old set of compasses from when I was at sea. Gosh, I just found them in the drawer this morning. So there's our course. So we're 0, 0. What do I do? Well, we're doing 12.5 knots. So my vector, and I need to have an idea of what my vector would be. So let's see. So speed equals speed times time equals distance. So speed here we're doing is 12.5 knots times the time is 12 minutes. But they need to be in the same units because speed is 12.5 knots. That's nautical miles per hour. So 12 minutes as a division of an hour, 6 minutes is 0.1, so 12 minutes will be 0.2. How do I do this quickly in my head? Yeah, it's just maths, isn't it? So if I was doing 17.5 knots and I was doing 6 in 6 minutes, how far will I have travelled? Well, I just multiply it by 1 and move the decimal point. So 17.5 in 6 minutes, I would have travelled 1.7 miles. 1.75 miles, beg your pardon. Here, I've done 12.5 and I'm doing it in 12 minutes to give me a reasonable length of vector. So that will be multiplied by 0.2. So all I do is to move the decimal point over to make it 1.25 and then multiply it by 2, making it 2.5. Okay. So that's 2.5 miles. And that would be my vector. Length of my vector. Of own vessel. Okay. So here's my target. She came over on the screen and I picked her up on the 24 mile range. I acquired her with ARPA and I would have waited the 3 minutes, the minimum 3 minutes to be able to gain the information with any accuracy. I've watched her come through onto the 12 mile range and now she just pops in and she comes in here just on the 6 mile range and just see, so she just come at the edge there. The vector that I can see on her is this. Oh. Gosh. So what is it? What is she doing? The interesting thing is that I can see her course. Let's call her A. Okay, target A. Her course must be parallel to mine. Yeah? So let's have a look and see. I said that I would have been 2.5 miles. So let's just measure off on the bottom. Oh gosh, look at this. This is a 12 mile range scale and we're on a 6 mile. So this would be 1, this would be 2, this would be 3, this would be 4, this would be 5, and this would be 6. That could be just a little tricky if you weren't aware of that. Okay, so we're doing 12.5. So on here, that would be around the middle, 12.5. So 12.5 would take her to there. So in my head, I'm working out that this vessel here, in actual fact, if she was stopped and she was a lighthouse, then she would be that closer to me in 12 minutes, because I'm doing 12.5 knots. But in actual fact, she's coming down here. So she can't be stopped. She must be actually coming in the opposite direction. And because it's parallel to the heading marker, for the ease, what I've done is I've tried to explain, then her course must be 180. What would be her speed? Well, what I need to do is I need to just have a look and see what that would be. Now, that's just short of 2 miles. So call that 1.8. So she's done 1.8. So if I halve that, that would be 9 knots. No. Halve that goes to 0.9. Yeah, and then if I multiply it by 0.1, so that will go back, and that will be 9 knots. So her speed is 9 knots. Okay. What can I work out? Well, I can work out what her CPA and TCPA would be. Her CPA would be if I continued this line and then looked at right angles, so that's going to be the distance, and the distance is the time. But I know that this is here. Let's look at this. This is 12 minutes. This is 0. So if that's 12 minutes, that's going to be 4.5. 4.5, I take it to 2.25. Okay. So there she would have been in 6 minutes. So this distance is going to be half that distance, isn't it, approximately? So half that distance. So this must be a further 3 minutes on. So that would be 15 minutes. Yeah? Do we agree? This is guesstimates. Okay? Remember, when we're looking at the radar, we don't have the ability to actually measure to the same extent. So I'm looking for a good estimate. Okay, so what I can say now then is that the TCPA is going to be in 15 minutes time. Okay, and the CPA, that's going to be, that's the time of closest point of approach, and the closest point of approach is going to be this distance here. Let me just have a look, see. Over here, about 1.8, 1.9, 1.9 miles. Okay, so she's passing nice and clear of me down my starboard side. She's coming down on a reciprocal course. Okay, So for the purpose of, that's what we're looking for, okay? Let's see what else we can find out. Okay. I wonder whether you wanted to have a look and see what it would be like if I was to do the OAW triangle. Clearly A is where she is. Yeah? Because that's where she is now, at the minute that I'm seeing her. This is all forecast. Yeah? So provided that both of us maintain our course and speed, then she will follow this track down. If, however, I was to try and work this out as an OAW triangle, then what I need to do is I need actually to step this back, because this is a forecast. So in actual fact, she will be back here. Yeah? So that would be O. So to intents and purposes, because it just dropped off my screen, let me use the top of the page. Okay. So here, this is the distance that she's come down. So O must have been there. Yeah. So O must have been here. So where would W be? W would be 2.5, as we just said. 2.5. So W would be here. So I've got way of own here would be 0, 0, 0 times my speed, 12.5. So WA would be 180, and the time, we just looked at that would be 1.9. So that would be 9 knots. Okay. This is the actual plot. However, this is duplicated here. The only way that we can work this out really is to say that this is a forecast, but this is history. Okay. I hope you found that useful. There will be a few more to come. I'm signing off.